Hello everyone. In the previous lecture, we have discussed how to construct partitions, and with the help of the partitions for function defined on that interval, how one can calculate LPF, that is lower Darboux sum and upper Darboux sums. So we have to take example on that. We'll discuss this example. I have taken the example of parabola, that is f of x equal to x square on the closed unit interval, that is 0, 1, and this is the partitions. The LPF and UPF completely depend on how partitions you choose, not the function. So it is dependent on partition. So your function is x square, partition it is defined on closed interval 0, 1, and 0, 1 has this partition. So this is x0 equal to 0, x1 is 1 by 4, x2 is 1 upon 2, I will write it as 2 by 4, x3 is 3 by 4, and x4 is 1. So this is the partition. So let me denote the subinterval. So first subinterval will be 0, 1 by 4. Second subinterval of I is x1, x2, that is 1 by 4, 1 upon 2. Third subinterval is 2 by 4, that is 1 by 2, comma 3 by 4. And the fourth subinterval is 3 by 4 and 1. So since there are 5 points, you must have 4 subintervals, and you can observe that all are equally spaced. All are equally spaced. This is your closed interval 0, 1. Now I have taken this as 1 by 2, half of this and half of it 3 by 4. So there are total 4 subintervals. And look at this is parabola. You can see the graph of parabola is increasing. So function is increasing. One can calculate the maximum value on that particular subinterval, and minimum value, that is infimum in particular subinterval. Okay. Now what is delta 1? The length of first interval is 1 by 4. What is delta 2? Length of second interval is 1 by 4. They are this partition is such that all are equally spaced points. So delta 3 is 1 by 4, and which is also delta 4. So keep this in mind. And now let me plot the graph of this. The parabola in the closed interval 0, I will plot. So this is your one point, that is 1 by 2 by 4, that is 1 by 2. This is 1 by 4, and this is 3 by 4. And look out, this graph is increasing. So clearly, what is the supreme infimum of this in this interval? So I can see this is the highest value and this is the lowest value. So infimum in the first interval is 0. Supremum in the first interval is 1 by 4. Secondly, in this interval, look at this. At this point, graph has highest value. So point is 1 by 4. Okay, at point I am telling. So your x is the point 1 by 4. So its square, that is 1 by 16, is the supremum of that, and this will be the 0 square, that is 0. Second, on the second interval, you can see in this second interval at 1 by 4, x square is the minimum in this interval. So it is 1 by 16. And what is capital M1? It is 1 upon 2 square. I can write as a denominator all is equal. So at that point I have taken it as 2 by 4. So it is 4 by 16, although it is 1 by 2, 1 by 4. So M2 is this. Next, M3 we have to look at this interval. So this is the lowest value, and this is the highest value in this interval. So M3 is 4 by 16, that is 1 by 4, and capital M4 is at 3 by 4, that is 9 by 16. This is M3. Lastly, on this subinterval, you can see on this subinterval, at this point we have, okay, let me draw the graph in between only. At this point we have highest value. The highest value of the function M4 is 1, and in this the supremum infimum is 3 by 4 square, that is m3 is 3 by 4 square, that is 9 by 16. So all these calculations of infimum and supremum in particular subinterval. Now you want to calculate the lower Darboux sum with respect to these partitions. What is the formula for that? Summation r from 1 to 4 m r delta r. Since delta r is fixed, which is constant, you can take outside. So sum of all these lower values, 0 plus 1 by 16 plus 4 by 16 plus 9 by 16 and multiply by the common length, that is 1 by 4. So this value comes up 9 plus 4, 13, 13 plus 1, 14 by 16, 14 by 16 multiplied by 1 by 4. So it looks like 7 by 32. So this is the LPF. This is the value of LPF. Now we will calculate the upper Darboux sum. For that, you can take screenshot of this till then. We can find, keep this value in mind, 7 by 32. So upper Darboux sum, the definition of this is summation of all supremum values in each subinterval. There are total up to n, x0 to xn, like that you can think, and here values are, just now we have calculated 1 by 16 plus 4 by 16 plus 9 by 16 plus, I will write it as 4 by 4 as the purpose of addition, and 1 by 4 is taken common because each supremum is multiplied by the interval length, and interval length for this is fixed. So this value becomes, so 4 plus 4, 8, 9 plus 9, 18 by 16 multiplied by 1 by 4. You also check the calculation. So it is denominator 32, 9 by 32. It's 9 by 32. 9 plus 4, 13 plus 1, 14, 14. Okay. It's 9 by 32. This is the upper Darboux sum. And nextly, it is asked to calculate the oscillation of that. We know the definition of oscillation. Upper sum minus lower sum is nothing but the oscillations. I will explain this again geometrically. The omega PF is the upper Darboux sum minus lower Darboux sum. So upper Darboux sum just now you have calculated, it is 9 by 32 and lower was 7 by 32. So this is 2 by 32, that is 1 by 16, which is always a non-negative because UPF is always greater than or equal to LPF. So let me explain this diagrammatically, this example. Okay. I will draw a parabola like this, and at this you have one point here, you have 0, half, 1 by 4, this is half point, 3 by 4, and it is 1 by 4, and this is 0. Okay. These are the subinterval. Now on throughout this interval you can see the maximum value is 1 and minimum value is 0 for the function throughout closed interval 0, 1. But on each subinterval, so look at this first subinterval. Look at this first subinterval. If you need to calculate the small m and capital M for that, and here small m is 0 and capital M is 1 by 4 square, that is 1 upon 16. So if you see the position of this point is 1 by 4, 1 by 16, x comma x square. Then next this point has position, okay, this point has position 0 comma 0. This is x is 1 upon 2 and y is 1 by 4. For calculations I can write it as 4 by 16. Next Position of this point is 3 by 4 and 9 by 16, and position of this point is 1 comma 1 square. Okay. Now firstly we'll discuss about the lower Darboux sum. So on this interval, what is the minimum value? 0. So it is m1 multiplied by delta 1 value. So m1 is 0 and delta 1 is 1 by 4. So this is the 0 area rectangle. But when I calculate the capital M1, M1 delta 1, you can see what is the area of this rectangle. The highest value of this is 1 upon 16 and the length is 1 by 4. So 1 by 16 is the highest value of the function in that interval, and the interval length is 1 by 4. So it is 1 upon, okay, you can take 1 by 4 later on common. Similarly, now area of this rectangle, okay, I will firstly I will show you the lower sum only. So this area, this is for second, this is for third, and this is for third. So this must sum this 0 area portion. This is 1 by 16 into 1 by 4 portion. This is another rectangle area. This rectangle sum area is nothing but your LPF that you have calculated. So what is that LPF? It is just 7 upon 32. Now, so this is first on first subinterval, next on second subinterval, highest value is this, on third subinterval, and on fourth subinterval. You treat this as 1 by 1 because length is 1 and this is also 1. Diagram structure comes also. This has area 1. This has area, what area it has actually? The 9 by 16 is multiplied by 1 by 4. Okay, it's not 1, it's 1 is multiplied by 1 by 4. So this is 1 by 4 area. Actually it is rectangle. This is 1 and this much is 1 by 4 as we have seen. So this is 1 by 4 and this is 9 by 16. So 1 by 4 into 9 by 16 has this area. So this rectangle area, this rectangle area, this rectangle area, and this rectangle area comes of your UPF. And it has, we just now calculated, it has value 9 by 32. Now this rectangle minus 0 area rectangle, I will just shade it by black lines. So this is the difference for first. Secondly, this area minus this area will be this part. Lastly, this rectangle minus below rectangle will be this. And this is the last one. Okay. So this is the oscillation. This is the oscillation of that function. The UPF minus LPF is oscillations, and that we have calculated. If you calculate area of this rectangle, the oscillation becomes 9 minus 7, that is 2 upon 32. This comes to 1 by 16. You can find area of this rectangle plus area of this rectangle plus area of this rectangle plus area of this rectangle. This comes with the oscillation of that. Now one can make important observation here that if I increase the number of points in the partition, that means the width is reduced. What will happen? The oscillation becomes smaller and smaller. And if I have infinite number of points, then actual area of this x square you can calculate. That is by this touch was given by the George Riemann, who is German scientist. So this is all about the example in concern with calculation of LPF, UPF and oscillation of this. So you can just keeping changing function, one can take x square, one can take 2x plus 1, one can take even sin x, cos x. You take, there may be some type sort of this function increasing, decreasing, but on that interval you should be able to calculate supremum and infimum and sum of all that rectangle lower sum gives the lower Darboux sums, and upper rectangle, that is upper sum, gives upper Darboux sums, and difference of upper and lower gives the oscillatory sum for that function on given particular interval. So it is requested that you should try for different example. Till then we stop here. For more videos you subscribe my channel, that is Math Spark, and like the videos. Thank you.